Hey, what's up YouTube? Quick video to show you a little blueprint I just released on my Patreon as a tier 1 reward that allows you to spawn meshes along a spline with a decent amount of controls. So first you might want to create a list of static meshes to spawn here. They will be chosen randomly. The blueprint will create an instance static mesh component for each, or a hierarchical one if you choose to. Then you may specify the material to use for that mesh and if you want to create a dynamic instance of that material in case you want to tweak its parameters later on. You can also specify collisions here if you want any. Once you've done that, you can set the distance between each instance. You might choose if you want to stretch the step distance so that the last instance precisely reaches the end of the spline. You can randomize the step distance, so 1 here means an instance might randomly shift its position along the spline, forward or backward, up to half the step distance value. And also you may remap the spline distance, like tell the blueprint, hey, its normalized 0 to 1 length is actually, 0.2 to 0.8, and that will shrink the spline and claim the start and end points, right? Once you're happy with that, you may project those instances onto the ground. You can choose the direction of that trace, the trace distance and channel, and also to align instances based on the ground's normal. And then you may further randomize the location of these instances, either in spline space or in world space, or in both. And same for a fixed offset. Both those randomized and offset locations can be applied before or after the ground projection, depending on your needs. We also have control for the rotation. We may randomize it and or offset it. We may choose to override the rotation that is given by the spline, and if so, the rotation to set. And also possibly randomly flip each instance on a given axis by a fixed amount. Here, each instance have a 25% chance of being flipped 180 degrees in the y-axis. Same for scale, we might randomize it and choose how to apply this randomized scale value, offset the scale and override the scale given by the spline as well. Voila, quite a neat little blueprint that may help design and build your levels. Now let's take a look at the construction script used to do all this. So first I get the spline length, make sure the step distance we specify has a valid value, compute how many steps that step distance makes us do based on the spline length, choose the final step distance to use based on the stretch setting, and make sure the step count doesn't exceed a safety limit. In there, for each instance data we added to the list, load the static mesh asset, make sure it's a valid static mesh, add an instance static mesh component or a hierarchical one depending on the setting used, and add it to a list, set its static mesh, and if we specify the material as well, load it and set it. Here we set the collision based on the given settings. Once that is done, we check that we added at least one component. If so, we start a for loop based on how many instances we need to add. Each time we march forward on the spline based on the step distance and the randomized step setting. Also, we remap the distance marched based on that curve I mentioned if we choose to. Then get the spline transform at this overall distance. Override both the rotation and scale if we choose to. Then we might want to randomize and offset the location before or after the ground projection, so we do that. Randomize location based on the given space, and same for the offset. Then if we project instances to the ground, we line trace in the given direction for ground. If we hit anything, we replace that instance transform with the impact point, and if we do align instances with the ground, use that ground normal to compute that instance new rotation. And then we check if we wanted to randomize and offset the location after the ground projection. Down there I randomize the rotation, offset the rotation, same for scale, randomize the scale, offset the scale. And at last I may flip instances. In there, based on the specified axis and chance, I may add some fixed rotation on that axis to that instance rotation. That gives us a final transform that we use to add an instance to a component chosen randomly. once we added all the necessary instances, we double check that no instance static mesh components have no instance, because in case we added very few instances, the randomization might have selected the same mesh and thus added all instances to the same instance static mesh component, and so one or multiple instance components might be empty, and so check that, and if so, destroy those. And voila, that's it. Hope it was useful. It's available on my Patreon as a tier 1 reward. Thank you for your time and support. I'll see you in the next video. Take care. Bye bye.